Hey folks, so I want to make a video on psychokinesis, sometimes also called telekinesis or simply mind over matter. Now, this is quite a popular topic in our culture. It's in a lot of movies, a lot of books, and whatnot. And I do believe this is a real phenomena, but it's not like it's portrayed in our culture. So, you're not going to find a person concentrating on a giant stone and lifting it up in the air. No, this is a much more mild phenomena, but it's nonetheless a real phenomena. And that's also not to say that there have been instances in our history where there have been exceptional human beings that have demonstrated some pretty remarkable psychokinetic phenomena. But again, for the most part, this is a mild effect. Now, I want to look at the evidence. So let's look at this guy, Dr. Helmut Schmidt. He lived from 1928 to August 2011. He was a German-born physicist and parapsychologist. So he got his physics PhD in the University of Cologne, and he did many, many experiments in the parapsychological arena. But today we're going to be focusing on just one of his psychokinetic experiments. And the reason why I want to focus on this, number one, is that it's not known. I'm not aware of anyone ever talking about this. But number two, the results are more bizarre than you can imagine. So the results he showed is that not only does psychokinesis exist, but that psychokinesis can be retroactive. So in other words, you can have a psychokinetic effect in the present that is caused by someone in the future. So in other words, someone in the future can cause a psychokinetic effect in the present or in the past. All right. This is the concept of retrocausation. If that sounds absolutely bizarre, it should, because typically effects do not precede the cause. But that is exactly what his data was showing. So when it comes to psychokinesis, how can we test this phenomena? Where here is an example. Let us start with a coin toss. Okay, a coin toss is something generally regarded as random. You have a 50% chance of it landing on heads, a 50% chance of landing on tails. So if I say I'm going to have this coin tossed 10 times, and I'm going to ask you as a subject to concentrate so that when it lands on heads. If we do it 10 times and each time it lands on heads, well, we might begin to speculate that perhaps there is some kind of psychokinetic phenomena going on, because if it was a random process uninfluenced by anything, we would expect 5 heads and 5 tails, right? So this is a basic outline of how a psychokinetic experiment can work. But there are two problems in this case. So first of all, a coin toss is not a truly random process. The design of the coin, the way it's flipped, whether we're doing it outside, inside, if there's wind or whatnot, all these things can affect the process, thereby not making it a random process, thereby introducing other variables that might lead to, let's say, 10 out of 10 coins landing on heads. Okay, so the first problem is we have to find as close to a truly random process as we can. And then the second problem is, well, how do we determine when a process is now going beyond a probabilistic explanation? In other words, when we are surpassing the threshold of mere randomness and going into a more orderly scenario where we have to posit that there's some kind of influence on the system that might be causing this, something that might be causing every coin flip to land heads. All right, so we're looking at those two issues. Now, Dr. Schmidt developed an ingenious way using what's called a random number generator. And there's a lot of different versions of this online, but his specific one used the principle of atomic decay or radioactive decay. So basically, as a radioactive particle decays, it emits an electron. Now you can take something like strontium-90, which is what Dr. Schmidt used, which emits an electron 10 times per second. So in 1 second, you have 10 emissions of an electron. He then designed a device that had a Geiger counter. The Geiger counter would catch that electron, so to speak, and then that would then stop an oscillator. An oscillator which was spinning 1 million times per second between a heads and a tails result. So when the Geiger counter was triggered, it would stop the oscillator and it would either trigger heads or tails. In this particular device, a heads would yield a red light and a tails would turn on a green light. All right. So this basic device solves our randomness issue. All right. Using a natural phenomena, we come to the closest means of creating some kind of a truly random process. All right. Now, the second question is on randomness itself. And this is the concept of statistical significance. This is something you would often see in, let's say, a clinical trial. So if we're testing a new drug versus placebo, how do we know, or at what point can we say that the effects of the drug are not simply due to chance, or we could actually attribute to the drug itself? We can say that the drug is doing something that exceeds what the placebo might be doing. We're trying to calculate a difference, right? So this is the mathematical method of the statistical significance, and it can be represented in graphical form. So this is what's called a two-tailed test, generates this kind of graphical form where you can say 95% of the results would fall within this range, so to speak. But if we're doing a test with coins that can land either heads or tails, you would say 50-50 would land right in the middle. But if it was 55-45 heads to tails, it might land a little bit to the left. If it's 55-45% tails to heads, it might land a little bit to the right. So it gives you an idea that if it's a random process, it would fall somewhere here in the middle. But if we have something else going on, like let's say cheating, or an inordinate amount of times the flip lands on a single coin consecutively, we're getting to the very outer edges of this diagram. Okay, now what's graphically represented here, is a p-value of 5%. Okay, now if you don't know statistics, it doesn't really matter. The point is only that we want to generate a statistical significance of 5% or less in clinical trials. All right. So 1 out of 20, right? We want to say that there's a 1 out of 20 chance that this could be some kind of random process or is non-significant. All right. That's all you need to prove via a clinical trial that a drug is superior to placebo. Now, Dr. Schmidt's results, using a generator like this and having a subject try to make the red light go on more often than the green light, he was getting a statistical significance of 0.001 or a 0.1% difference. Okay? Again, for a drug, you only need to prove 5% or less, but for psychokinetic effects, he was generating a 0.1% statistical significance, or 0.001. In other words, this was not due to random chance. He was proving, ostensibly, prima facie, a psychokinetic phenomena. And he did many of these experiments. But again, today I want to focus on the one that was proving retrocausality. Now, because his experiments really aren't that well, you can't really find them, I had to create a PowerPoint. But the information I'm getting for this comes from the work of Dr. Stephen E. Braude. from his book ESP and Psychokinesis, Philosophical Examination. And I really like the work of Dr. Stephen E. Braude. He was a emeritus professor of philosophy at the University of Maryland. I like him because he introduces a lot of rigor and scholarly information into this topic when, we all know that there's a lot of, let's just say less legitimate sources out there. All right, so this is where I'm getting this information from, and it's thanks to him that I can now share this with you. So I had to create a PowerPoint because, again, this information just is not readily available. And so what Dr. Schmidt used was a modified random number generator, and it's represented by this box here, RNG. And what this did was that he made it very difficult for the device to trigger a heads. There was only a 1 out of 64 chance that the RNG would strike at heads. There was a 63 out of 64 chance to get tails. And the idea of this was, how long does it take for this random number generator to generate a heads? Now, if you do the math, it comes to 6.4 seconds. All right. The reason being that strontium-90 again emits an electron 10 times per second. So if it requires 64 times to generate a heads, then doing some basic math, you're going to realize that it would take 6.4 seconds on average, and this is an estimate, for us to get a heads. If this is kind of complicated, that's fine. I was never particularly fond of statistics or math. All you need to know is that what we would expect for this to be a random process would be that it would take this 6.4 seconds to get heads. Now, the goal we want to do is, can we reduce the length of the experiment? So what would happen is Dr. Schmidt would have a subject listening into headphones, because when the RNG would hit heads, it would trigger a click. And what the subject was asked to do was not to focus on the click, nor to try to make the click happen more frequently. Rather, Dr. Schmidt asked the subject to sit in a relaxed position, imagine themselves being in a forest, and the click representing a bird sound or bird chirping. And he speculated that this passive expectation would trigger a subconscious psychokinetic effect that would reduce the length of the experiment. In other words, instead of taking 6.4 seconds to hit tails, or heads rather, we would see it hitting heads at a much sooner pace. All right, so he did this particular experiment, and again, all you need to know is that if it was a random process, we would expect it to take 6.4 seconds. Anything less could potentially be a psychokinetic effect occurring. So these were his results. Now, first of all, he made a control to make sure that the device was working properly and randomly generating results. And so he found that out of 4,000 trials, he was actually getting 6.48 seconds is how long it took to hit heads. Okay, so again, our estimated time was 6.4. In the controlled experiments, he was getting 6.48. So that's really close. That's within random limits. Now, he did this 2 times. The first time he did it, he took 20 subjects. Each person had 20 runs each. And he found that, amazingly, the time was reduced to 5.42 seconds. So instead of 6.4, it took 5.42. And this, using statistical significance, was found to be 0.001. So again, a 0.1% chance that this could have been a fluke. All right. In other words, using, if we compare it to, let's say, the clinical trials with a medication, this was proving that there was a psychokinetic phenomena occurring. So he redid the experiment. He did a confirmatory trial, and this time he used 30 subjects, 20 runs each, And again, the average wait time was 5.53 seconds, another statistical significance of 0.001. Again, a 1 out of 1,000 chance that this could have been due to a fluke. Okay, it's not a fluke. There was, in fact, a psychokinetic phenomena occurring here. But now this is the really revolutionary part of his experiment. So he did the same experiment, but this time the RNG, instead of being played live to a person, the results were recorded on a stereo cassette tape. All right, now if you're younger than a millennial, you probably won't know what this is, but information used to be gathered on stereo cassette tapes. And what he did was he made two tapes generated. Okay, he called them A and B. The intention was that one of them would be played to a subject and the other one would just be used as a control. No one listened to these tapes prior to the experiment. They were generated in a room that no one was in, so the device was completely isolated. And again, two tapes were made, and the experiment nor the subject knew which tape they would be getting. So that's an important aspect to understand of this experiment. And then again, instead of a live random number generator being played, Dr. Schmidt played the recording to the person, and the subject was again asked to imagine themselves in a forest. The click represents a bird chirping, and they're supposed to passively expect the click occur more frequently. And the goal was the same, to reduce the length of the experiment. Now, we would expect that there should be no effect on the tape, right? If it's pre-recorded, well, then the results should be purely random. But here's what happened. He got similar results to when he was doing the live experiment. So the first trial, 20 subjects, 20 runs each, it took 5.64 seconds. Again, if it was a truly random process, it would take 6.4 seconds. But with these subjects passively expecting the click, it was reduced to 5.64, which was again a 0.001 statistical significance. In other words, he's proving something is happening here that cannot be accounted for in a random process. Psychokinesis is real. Now, here's the other thing that's pretty mind-blowing. So remember, he made two tapes. One was not meant for the experiment. One was a pre-recorded control tape. And he found that the average wait time to get heads was 6.31 seconds, which is within chance. Again, going back to that statistical significance, you have the graph there. There's some wavering. You might sometimes get a little bit more heads than tails. That's what this means. But it's within chance statistics, so it's non-significant. This is absolutely mind-blowing because it means that the psychokinetic effect is not dependent on whether the targets were generated during or before the test. Okay? So somehow, because the subjects had no idea which tape they're getting, somehow in a universal process, the correct tape had to be affected. I mean, this is just, it's mind-blowing, absolutely mind-blowing. So what this points to is the implications concerning time, right? I mean, time is not necessarily linear. If you have an effect preceding the cause, if you have a future person affecting something in the past, I mean, this just completely ruptures our current paradigm about space and time. And it seems to imply that there is some kind of general psychokinetic effect that we are all exhibiting. Because remember, in Dr. Schmidt's experiment, he didn't require concentration. You didn't have to forcefully try to make the random number generator's duration decrease. You just needed a passive expectation. And so maybe that when you have someone who is lucky and other people who were described as unlucky, perhaps their expectation is somehow affecting the world around them. And this just goes to show you how much power each of us has within ourselves. So that is the end of that experiment. But again, I wanted to share this because this is information that is simply not readily known. And also because you are not a meat popsicle. There is more to a human being, there's more to you and us than simply being robotic consumers in a decadent society. So I hope this was of some interest and importance. I hope this inspires you to learn more about this topic. And I don't recommend going off of Wikipedia. I do recommend going off of good authors and books. But maybe just as a final point, um, Wikipedia has some of the negative aspects that it attributes to Dr. Schmidt. So, for example, one criticism that you will read is that the effects were modest. So, it's true, these effects are modest, but that's irrelevant. I mean, whether they're modest or not is not the point. The point is that something is occurring that cannot be attributed to a random process. There's some kind of effect that is not reduced to a physical phenomena that's occurring here. And, the people that were studied in Dr. Schmidt's experiments, these were just ordinary people. I mean, this is not to say that it's impossible that an exceptional human being exists that can do, you know, moving a rock or whatnot. But for the most part, this phenomena is mild, is modest. And the other thing they were saying was just I think they're trying to attack the statistics of this. But again, as I showed, Dr. Schmidt did do controlled experiments. And when these devices were used under controlled scenarios, they were generating random results. Okay, the 6.48 that I discussed in the PowerPoint. The only difference was there was no subject trying to concentrate on affecting the device. So again, a lot of bunk on Wikipedia. I use this usually just as a passing reference. But again, do study this issue. Do learn about human consciousness and human potential. It is a truly important subject. All right, take care of yourselves.